Okay, so this 1 through 5 was supposed to be there. So Rolle's theorem, remember Rolle's theorem, you don't actually have to know that name at all. It's just a very specific case of the mean value theorem. It's the case of the mean value theorem where the average rate of change is 0. So if you wanted to know if Rolle's theorem was going to apply, you would do f of 5 minus f of 1 over 5 minus 1. And if we plug that in, negative 25 plus 30 would be 5 minus 6 would be negative 1 minus f of 1, which would be negative 1 plus 6 minus 6, so negative 1. Okay, and then you get 0 over 4, which is 0. So this is why this is called Rolle's theorem instead of just mean value theorem. The average rate of change came out to be 0. But the other side is still supposed to be instantaneous. So that would be the derivative piece. So ultimately, if you want to know where the average rate of change equals the instantaneous rate of change, which is what this is telling us, it would occur when this equals 0. So for this question, I'd say at x equals 3, Rolle's theorem is telling us that the average rate of change and instantaneous rate of change are both 0. Okay, and to give you a visual of that, because you don't usually have a calculator, if I was to graph this function and restrict the domain to 1 to 5, okay, here's what the function looks like. So here's the average rate of change, which is 0. And then the place where the instantaneous rate of change is also 0 is at x equals 2. Or x equals 3. Oh, this is actually, okay, I almost miscounted there. Maybe I should draw 0. It was 1 to 5. So the average rate of change from 1 to 5 is 0, and when x equals 3, it's 0. I was thinking it was 2 because I didn't see the y-axis over here. But, let me see if I can sketch that in. Average rate of change is equal to instantaneous rate of change at x equals 3.